Hello everyone, welcome to Chapter 1, Lesson 1. We're on page 7. To scan the lesson list, two headings we'll be learning. We'll be doing greatest common factors, which will be GCF, and least common multiples, which would be LCM. So vocabulary startup, a common factor is a number that is a factor of two or more numbers. The greatest of the common factors of two or more numbers is called the greatest common factor. The least non-zero number that has multiple of two whole numbers and least common multiple, LCM, of the numbers. The word definitions may be confusing, but we're going to go deeper into this as we go along. So we know GCF stands for greatest common factor. This is define greatest. That is going to be largest of a set of values. Define common. The same features among several numbers. And then factor, a number that is multiplied by another number. LCM stands for least common multiple. Least is the smallest of a set of values. Common is the same as here, and multiple. The product of a number and any whole number. Real world link. Brian is making balloon arrangements. He has 8 blue and 12 green balloons. What is the greatest amount of arrangements he can make if he wants to make them identical? So our hint right here is going to be greatest. So we're going to be looking at the greatest common factor. So the factors of 8 is going to be 1 times 8 and 2 times 4. Those are the factors of 8. The factors of 12 is going to be 1 times 12, 2 times 6, and 3 times 4. Those are the factors of 12. So what are the greatest ones that are common? It's going to be 4. 4 is the biggest number that is common amongst both 8 and 12. So this is going to be 4 arrangements. So just a reminder, a factor, a number that is multiplied by another number. So 1 times 8, 2 times 4, those are factors. So we're going to first practice find the greatest common factor. There are 1 slice servings of 3 types of cake on a table. Each row has an equal number of servings and only 1 type of cake. What is the greatest number of servings in each row? To solve this problem, use common factors. So we're going to set it up the same way that we set up the previous problem. So I have my numbers here to the right of my table. 10, 15, 20. I made the factors of 10 and we ordered them from least to greatest. So we have 1 times 10 and 2 times 5. The factors of 15 is 1 times 15 and 3 times 5. Factors of 20, 1 times 20, 2 times 10, and 4 times 5. Now, they highlighted in red the common factors. Of course, 1 is always going to be a common factor. But we want the greatest common factor, which in this case, there's a 5 in a factor of both in all three of 10, 15, and 20. So the greatest number of pieces of cake that can be placed in each row is 5. So go ahead and try A. So to the right, I have all my factors listed. So 49, we have 1 times 49, then we have 7 times 7. I only need to put 7 once, I don't need to put it twice, that's why there's only 1 7. For 42, we have 1 times 42, 2 times 21, 3 times 14, and 6 times 7. For 21, we have 1 times 21 and 3 times 7. If you notice, I've already highlighted the greatest common factor. So she can charge $7 for each bracelet. That's the most she can have charged. So here's the other way of finding greatest common factors. You can make a prime factorization tree. So we have 12 and 18. So I'm going to tell you how they set this up. So they have factors of 12. They did 6 times 2. Now, 6 is composite, 2 is prime. 2 is prime, so I can just kind of bring that down. 6 can still be broken down into 2 factors, 2 times 3. Now for 18. For 18, they did 9 times 2, and the 2 is prime. We already established that. So I'm going to bring that down. We can still break down the 9 into prime numbers. That's going to be 3 times 3. So the other way we can do this, I'm going to 12 equals 2 times 2 times 3. 18 equals 2 times 3 times 3. Now what we need to decide is the common factors. So 2's are common, and 3's are common. So those are my common factors. So I'm going to write down my common factors over here to the left. So my 2 times my 3 were both common in 12 and 18. So 2 times 3 equals 6. So our greatest common factor between 12 and 18 is going to be 6. I did this by finding the prime factorization of 12 and 18, and I took the common factors from 12 and 18 to get my 2 and my 3. So go ahead and try B, C, and D. So I have the answers for B and C. I'm going to go over D with you guys. So here's my prime factorization of 12 is 3 times 2 times 2, all prime numbers. 66, 2 times 3 times 11. So my common factors, I can pair up these 2's and I can pair up the 3's. So I have 2 times 3 equals 6. And I do know there's another 2 here, and there's a 2 here on the right side. But once the 2's are paired up, once a number is already paired up, you can only use a number once. So even though there's multiple 2's, I can only use one of those 2's. For C, 18 is 3 times 3 times 2, which we already established in the example above. 30 we split up to 3 times 10, so that's 3 times 5 times 2. Now our common factors, I can pair up a 3, and I can pair up my 2's. So I have 3 times 2 equals 6. Now for D, I have my prime factorizations already set. 32 is going to be 2 times 2 times 2 times 2 times 2. 48 is 2 times 3 times 2 times 2 times 2. So I'm going to pair up this 2 with this one. I compare this 2 with this 2. I compare this 2 with this 2. And I compare this 2 with this 2. So that means I have 4 2s. So 2 times 2 times 2 times 2, which is going to equal 16. So now that we did factors, now we're going to be doing multiples. Multiples it could be a little bit similar, but they do have some differences. So we're going to use a number line. This is find the LCM of 2 and 3. Method 1. Put a red X above each non-zero multiple of 2 and a blue above each non-zero multiple of 3. So we have the red X's, they are counting by 2. So 2, 4, 6, 8, 10, 12. The blue X's is counting by 3's. 3, 6, 9, 12. Now we want to look at the numbers where they match. 6 and 12. 6 and 12 both are multiples of 2 and 3. But now we want to look at the least common multiple, and that least common multiple is going to be 6. So our answer would be 6. So method 2 is using an organized list. So how we do this is I write down my multiples I'll be starting off with, and now I just count by 2's. 2, 4, 6, 8, 10, 12. Same with 3. 3, 6, 9, 12, 15. Now if I look, I have some common multiples here and here. Made a slight mistake. So I have my multiples of 2 and my multiples of 3. I still have common of 6 and 12, but my least common is going to be 6. Example 4. Find the LCM of 14 and 21 using prime factorization. So just like before, they have the prime factorizations of 7 and 2. The main difference between this, I'm actually going to write them down. I'm going to write them down for us. So 14 equals 2 times 7. 21 equals 2 times 3. No, it doesn't. 3 times 7. Here's the main difference. Our 7s, we still pair those up. But our 7, we only write down once. So 7. The rest of the numbers, 2 and 3, now I write down the rest of my numbers. So 7 times 2 is 14, times 3 is 42. So my least common multiple is 42. And I'm going to go over that one more time. Prime factorization, my 7s pair up, so I only write it down once. And then I don't have any more pairs, so I just write down the rest of my numbers. 2 and 3 equals 42. So I'm going to do E with you guys. 2 is already prime. 6, 2 times 3. So my 2's pair up, so I only write that down once. 2. And I still have leftover 3, so times 3. So my least common multiple for E is 6. So go ahead and try F and G. So I'm actually going to solve these with you guys. I have my prime factorizations of 4, 5, and 10. 5 is already prime. So my 2's pair up, so I write that down once. 5's pair up, so I write them down once. I have a leftover 2, so I multiply it by 2. 2 times 5 is 10, times 2 equals 20. 3, 5, and 7 are already prime, so prime factorizations is pretty easy. I don't have any pairs, all I have is leftover numbers, so in this case, I'm going to multiply all my numbers together. I'm actually going to do 3 times 7 first. 3 times 7 is 21. Times 5 is going to be 105. So the last thing is example 5. Ernesto is painting every 2 weeks. Kamala has party class every 5 weeks. Ernesto and Kamala met the same art building for class this week. How many weeks until they see each other again? So we do multiples of 2. It's 2, 4, 6, 8, 10, 12, 14. Multiples of 5, 5, 10, 15, 20, 25, 30. 10, and this they did the list method. 10 is both common, and that's our least common multiple. So it'll be 10 weeks. And that's the end of the lesson, so thank you for watching.